Hey kids, this is Mr. Kozee for part 2 of lesson 2. With me here is Natalie, who is trying really hard to eat my headphones and go cannonballing out of my lap and down to the floor. So if things get if you hear a tussle or you hear cooing, that is my daughter. We are talking about numerical data. Our previous video was categorical data. In numerical data, categories consist of ranges of numbers. Now, what I mean is, let's say that that this is my data for something. The number of times you have visited a fast food restaurant in the past month. To make my categories, I could say, anything 1, 2, and 3 will be a category. Anything 4 and 5 and 6 would be a category. Anything 7 and 8 and 9 would be a category, and so on. Okay, and then I would just go through my data and say, okay, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pieces of data between 1 and 3. There's 1, 2, 3, 4, 5, 6, 7 pieces between 4 and 6, and so on. And that's essentially how you categorize numerical data. Now, what those ranges are, it depends. There could be some external concern determining those ranges. For example, grades. Our grading scale is 0 to 64 is an F, 65 to 73 is a D, 74 to 83 is a C, and so on. And those ranges are arbitrary. They are not evenly spaced at all, but that's what they are. And so if I were working with let's say quiz scores, that's what I would use. Absent that, you want categories that are evenly spaced across your data, like we have here. They should be the same width. So, like, my last category shouldn't be just 10. It should be 10, 11, and 12. And there may or may not be numbers up to 12, but that's fine. It's weird to have a category that's more narrow than the others. And then you shouldn't have an overlap, because you want every number to clearly go in one category. I'll be honest, the computer does most of this for you. The real question is, how many categories do you want? Because if you have too few or too many, it's really hard to see how your data is distributed. So let's go over to Google Sheets and click on the Histogram tab. Okay, and let me show you a frequency histogram. Now let's while you are doing that, let me tell you a few things about a frequency histogram. And let's get a larger slide here. This is going to remind you of a bar chart, and they have a lot in common. The big difference is the x-axis of a bar chart is basically a space for you to label your bars. Okay? In a frequency histogram, the x-axis directly corresponds to your data. Okay, so you physically graph on the x-axis where the data is. For example, let's look at this little histogram here in the corner. This is showing us that looking at the ages of women visiting the library, there's one person aged 20 to a little bit less than 30. There's one person age 30 to a little bit less than 40. There are three people age 30 to less than 40. There are 7 people age 40 to less than 50, and so on. Where the bars physically are on the x-axis corresponds to the data that you are representing. And therefore, your bars touch because your categories cover all of your data, and your categories don't have any holes in them. Okay, and this is the fundamental difference between a histogram and a Pareto chart. Now, I'll be honest. There's not one universal standard for how you construct a histogram, other than what I just said. I've seen a couple of different setups in my time. The setup that I'm going to talk the most about is the one that you see here and the one that Google Sheets does, where the left edge of every one of your bars is the lower limit of each category. It's the start of each of your categories. And the right edge corresponds to the lower limit of the next category. So like here, this first category starts at 20 and goes up to just a shade less than 30. Okay. Now, because we are talking about ages, you could reason that this is 20 to 29, but that's not how I graph it, because I don't want any holes in my categories, and I don't want any holes in my bars. So this is 20 to just a shade less than 30, 30 to just a shade less than 40, and so on. I've seen other presentations where the left edge is the lower limit and the right edge is the upper limit, and then there's a little bit of fudging that you do to make all of the bars touch, and that's fine. Google Sheets doesn't do this, so I'm not going to fixate on it. Now, to get the bars to touch, there's a lot of ways you can make this happen. The way that we see here is how Google Sheets does it. So let's take a look at that. Escape out and let's flip over to that tab. So to make a histogram, you highlight the numbers. These are survey results from a previous class. I asked them, each student, their height in inches. For frame of reference, 5 feet is 60 inches, 6 feet is 72 inches. So I'm just going to select all of these numbers. I'm going to go to Insert Chart, and Google Sheets will actually default to a histogram. So here we see in the data, 4 people fall 60, 61, 62, 63. 10 people are 64, 65, 66, 67. 8 people are 68, 69, and then so on. Okay. Google, this tech tool, and this is true for any kind of tech that you use, it will set up the categories for you. It's just how many categories do you want. So under histogram, you can fine-tune the number of categories that you want. Now, you do that by specifying the size of each category, how many values you want to fall in each category. Auto, it tries to pick a reasonable number. The trick is, if you pick categories that are, if you make your categories too small and you have too many of them, it's harder to see how your data is distributed. I mean, you can look at it and kind of figure it out. Like I think most of the data is 66 to 68, but I've had to look. I mean, the whole point of a chart is so that you don't have to work things out yourself. The chart shows you what the data is. You don't have to deduce anything about how the data is distributed. So it's not good to have categories that are too small and where you have too many. It's also not good to have categories that are too large and you have too few. You're looking for a sweet spot, and in this here you can enter in the size of each category. So so 1 is too small, 10 is too large. How about 3? How about 3? And here with a category size of 3, we see a pretty good. We see how things are grouped. There's clearly most people are 66 to 67. And there's slightly fewer that are 69 to 71 inches. There's one extra tall person out here. So this is how this is the puzzle with setting up a histogram. It's not the actual setting up of the categories, but how many categories do you want, and you're looking for that sweet spot. Let's move on and talk about a dot plot. A dot plot is a fast and dirty way of presenting data, and so that you can see how it is distributed. It works best when you have a relatively small number of unique values. So you have a lot of repeats in your data. How it's constructed is you plot out all the answers on the x-axis, and you for each piece of data you make a dot above that answer. And if multiple people have the same answer, you just stack up the dots. So let me show you how to do this in Google Sheets. I will say that this is a little bit of a hack. A dot plot is something that you would tend to do more manually than in a computer. Though there are stats tools that do generate dot plots. So let's go back to our spreadsheet and move over here. Here I surveyed a previous class. How many hours did you sleep last night? The first thing I'm going to do is select these numbers. I'm going to right click, and I'm going to sort these numbers A to Z, low to high, so that these are in order. Over here I'm going to make another column called count, and I'm just going to count up how many of the same value I have. And this is going to look weird because this is a hack, but it works. So count 1 4, 2 4s, 3 4s, 5 1 5, 2 5, 3 5, 6 1 6, 2 6, 3 7s, 2 8s. Okay, now I'm going to select both of these columns. I'm going to go to Insert Chart. It's going to try to make a histogram with these numbers. I don't want to do that. Instead, I'm going to scroll up here to Chart Type, and I'm going to pick the Scatter Chart. And now we see the dots. Now this is really zoomed in, and it's kind of hard to see the whole chart. So I'm going to go over here to Customize, and on the horizontal axis, I'm going to set the minimum value to be a little bit less than my lowest number. I'm going to set the maximum value to be a little bit more than my highest number. I'm going to do the same thing on my vertical axis. I'm going to I'm going to start at 0 and go like from 0 to 5. Okay, and now I can kind of see the stacking of the dots. Okay, this is a different kind of presentation, but it does show me very quickly kind of where the dots are stacked and where they are concentrated. So this is a dot plot. Let's move on and talk about a stem plot. You've seen this as a stem and leaf. This is more of an organizational tool. And the idea is that you take each data point and you break it into two parts using the place value of the digits themselves. I could talk this out, but let's just show you an example. So let me pick my red pen here. So I've got a bunch of numbers. I'm going to look, each of these are 2 digits. So I'm going to look at the tens place because the tens place represents my stems. Okay, I think my low number is 50. So I'm going to go, my first stem is 5. My next stem is 6. My next stem is 7. My next stem is 8. My next stem is 9. I don't think I have any tens. Okay, so those are my stems. And now my leaves, for each number, like 64. For 64, 6 is the stem. The ones place is my leaf. So that's 64. 82, 85, 99, 96, 81, 97, 80, 81. Okay, so as I go through these, I use the tens place to tell me what stem I'm in, and then the ones place is I write that leaf. So 80, 84, 87, 98, 75, 86, 82, 78, 81, 86, 80. There's the 50, 50, 84, 88. I'm running out of slide. 83, 82. Okay. And then a common thing that you do is you go through each of your leaves and you put your leaves in order, and that's a way of showing sorting your list. As you make the stem and leaf plot, you put the list in order. One thing that's very important when you make a stem plot is to provide a key, like a stem of 6 and a leaf of 4 is the number 64. And that's important to show because it could also represent 6.4 or 0.64. It could represent anything. So you need the key to show you what the different combinations indicate. Okay. So just a quick quiz for yourself. Tell me what that number represents. What that leaf represents. This is the number 78. How about this leaf? This is the number 96. This is also a way of seeing to some extent how your data is distributed. Like, most people got something in the 80s by far, which is good to know because if these are our test scores, 80s cover C's and B's. Okay. All right. Let's move on. We are almost done. I promise. Let's talk about a box plot. This is also called a box and whisker plot. This uses 5 numbers from the data: the low and the high, the median, which is the middle number of the data, and then the first and third quartiles. Now, I'll talk a little bit about the first quartile is it kind of covers the first quarter of your data. The median is the middle. The third quartile is the third quarter of your data, and then the high number. So these numbers here kind of cut your data into 3 pieces or 4 pieces. They cut them into quarters. So what you do is you mark these out on an x-axis, and you make a box from the first to the third, you draw a line at the median, and you extend whiskers out to the low and the high. I could explain this to you, but I think a better way is to just show you. So this is a box plot that represents the number of tickets sold during a 30-day run of a popular vampire movie. Now this is in hundreds, the number of tickets sold in hundreds. So let's take this apart. This line here represents the median. So half of the time we sold more than 400 tickets in a day, and half of the time we sold less than 400 tickets in a day. Our worst day was we sold just 100 tickets. On the busiest day, we sold 900 tickets. So the edges of the plot represent the low and high numbers in the data. Okay, the median is right here in the box. It's where we split in half. So half of the data is more than 400, and half of the data is less than 400. Okay, the bounds of the box are what we call the middle 50%. So, and this gives you a sense of a typical day. Half of the time we sold between 300 and 600 tickets in a day. Okay, so what a box and whisker plot does is it gives you a way of seeing how the data is spread out. Because the thing to remember is that your left whisker contains 1/4 of your data. So 1/4 of the time we sold between 100 and 300 tickets. And if the left whisker is long, it's still 25% of your data. It's just that 25% is really spread out. Okay? If the left whisker is short, if it's small, it still represents 25% of your data, but it's clustered in that area. Okay? And the same is true for each other part of the graph. From the left edge of the box to the median is 25%. So we see a cluster here because this is a small piece. 1/4 of the time we sold between 300 and 400 tickets. The right edge the right half of the box is 25% of the data. So 25% of the time we sold between 400 and 600 tickets. And then 25% of the data is in this long whisker. It's just more spread out. There's the same number of tickets, or the same number of days in each section. There's 25% of my data in each section. This shows me where it's clustered and where it's spread out. Okay, and that's the idea behind a box plot. Now, we do have a project off of this, which I'll post now, and but it isn't officially assigned until next week. But I do have a homework assignment that's immediately assigned out of this. It's on Schoology. It's called comparing two box plots to see. Just pull it up and you'll see it. Okay. And then if you have questions about it, save it for our office hours. All right, guys. I know this was a long video. If this were given live, this would be a 2-day lesson. So I thank you for staying with me because I know there's a lot here. Take care.